Let's have look at this question. Find the y dx for y is equal to 3x plus 5 divided by x minus 1 over 2 root x. We're asked to differentiate this function, and to differentiate this function is pretty simple. We can use the addition and subtraction rule of differentiation to differentiate this function. So given that we have y is equal to 3x plus 5 divided by x minus 1 divided by 2 root x, I can call this equation 1, just rewriting the question. So transforming equation 1, we can have that y is equal to 3x plus 5 over x is the same thing as saying 5 multiplied by 1 over x minus 1 over 2 root x is the same thing as saying 1 over 2 multiplied by 1 over root x. So I can call this my equation. Okay, I can say this can be transformed to 3x plus 5 multiplied by x to the power of minus 1 minus 1 over 2 multiplied by x to the power of negative 1 over 2, and I can call this equation 2. So basically what I've just done here, the transformation I just did here, looking at the rules of indices, if you have that a to the power of minus n is equal to 1 over a root n. Likewise, we have that the square, the law of sorts, if you have that, you have this is the same thing as saying the nth root of m to the power of m. Basically, that's why if I have x to the power of 1 over 2 is the same thing as saying the square root of x to the power of 1. And of course, 1 here just means you can decide not to put that 1 there. It's just putting it for reference sake. So that was how I was able to transform. That was how I was able to transform 1 over 2 root x, 1 over root x rather, to x to the power of negative minus 1 over 2. So the reason why you're having a negative sign here is because this is not just root x we are transforming, you're transforming 1 over root x. So that is why I'm having a negative sign here, because it is 1 divided by root x. So that's why this negative sign is there, following this law of indices. Alright, so having that crashed out, we can then proceed from equation 2 by saying that if I transform equation 2, y is going to be equal to 3x plus, this is going to give me 5x to the power of negative 1 minus 1 over 2x to the power of negative 1 over 2. Okay, so having this now, I can use the addition subtraction rule of differentiation to quietly differentiate this. And also, while using the addition and subtraction rule of differentiation, I'll also employ the power function rule and also employ the scalar multiple rule. So I'll be using 3 rules in just this to differentiate this equation. So these 3 rules just comes, the steps I'm going to use. I'm going to be borrowing the scalar multiple function rule, also borrow the power function rule, also borrow the addition subtraction rule. So putting all that into context, if I have to differentiate, so the y over the x is equal to, this is going to be 3x. Okay, so this is going to be 3. I'm going to differentiate. So I'm going to have 3 dx plus 5 x minus 1 over dx minus 1 over 2 x minus 1 over 2 x. The y over the x is going to be equal to 3, and when 3 is a constant, so I just use that. That's a scalar multiple function rule, so I'm using the constant to multiply whatever I differentiate. So if I differentiate x, I'm just going to have 1 plus 5. When I differentiate x to the power of negative 1, differentiating x to the power of negative 1 using the power function rule, I'm going to have negative 1 multiplied by x to the power of minus 1 minus 1. That'll just be negative x raised to the power of minus 2. Whenever you differentiate x to the power of negative 1, you get negative x to the power of negative 2. So I'm going to put that here, negative x to the power of negative 2. And then I'm going to proceed by saying 1 over 2. If I differentiate x to the power of negative 1 over 2, when I differentiate x to the power of negative 1 over 2 using the power function rule, is going to be negative 1 over 2 multiplied by x, negative 1 over 2 minus 1. And that's going to be negative 1 over 2 x to the power of negative 1 over 2 minus 1 is going to give me negative 3 over 2. I'm going to have negative 3 over 2. That's going to be negative. That's negative 1 over 2. If I differentiate x to the power of negative 1 over 2, I will have negative 1 over 2 x to the power of negative 3 over 2. So I can decide to call this equation 4, or whatever equation I want to give it, and decide not to. So if I proceed, I have the y over the x is equal to 3 multiplied by 1 is 3. Yes. Now 5 multiplied by negative x is going to be negative 5. Here is going to change to negative 5x to the power of negative 2. And then negative multiplied by the negative, this negative sign here, multiply this negative sign here, I'm going to have positive. So I'm going to have positive, and then 1 divided by 4, because 2 multiplied by 2 is 4, and then x to the power of negative 3 over 2. And then if I proceed further, I'm going to have, this is the same thing as saying the y over the x is equal to 3 minus, this is going to be 5 multiplied by 1 over x to the power of 2, because that's what x to the power of negative 2 means, 1 over x to the power of 2, using the laws of indices that I earlier pointed out. So this is also going to give me 1 over 4 multiplied by x to the power of, okay, so this is going to be, let's transform what x negative 3 over 2 means? That simply means 1 over the square root of x to the power of 3. That's just basic simple laws of indices, where you have the function a raised to the power of m over n is equal to the nth root of a to the power of m. That's just basically what I've done here. In this case, here is our m and this is our n. So if we have that in place, this is what we're going to have. So that was how I arrived at this. That was how I arrived at this. So if we have this is, let's recall that x negative 3 over 2, recall it's the same thing as saying 1 over the square root of x to the power of 3. So that's what I'm going to have here, 1 over square root of x to the power of 3. Okay, this is something as saying the y over the x is equal to 3 minus 5 over x squared plus 1 over the 4th root of x to the power of 3. So that's going to be the what we get when we differentiate that equation, that function. You can feel free to ask questions in wherever part you don't understand. Feel free to drop your questions and I'll attend to them once I come across them. Let's also find the y dx, or y is equal to 4x squared plus 3x minus 2. I want you to pause this video and try to work this out yourself. See if you're going to get the answer correctly. Just pause the video, work it out yourself, come back to the video and let's work it together, and then you're going to score yourself if you got it right. Wherever you didn't get it right, you're going to learn from the mistakes you've made and correct yourself. All right, welcome back. I believe you were able to solve that question and you got it right. In case you didn't, or you're not sure if you did, let's work this out together. To solve this is exactly what I'm going to do. I'm going to be saying I can rewrite this as 4x squared plus 3x minus 2 over the square root of x. I can rewrite this as saying 4x squared divided by the square root of x plus 3x divided by the square root of x minus 2 divided by the square root of x. I can also transform this to say y is equal to 4x squared multiplied by 1 over the square root of x plus 3x multiplied by 1 over the square root of x minus 2 multiplied by 1 over the square root of x. With this, I have not changed anything because 4x squared multiplied by 1 is the same thing as 4x squared over square root of x. So I have not changed anything right there. So proceeding, I'm just doing this to transform my function to look like the addition and subtraction rules. So I can use the addition and subtraction rule to solve this. I'm just doing some transformation. So this is how I'm able to transform this equation to be able to differentiate using the addition and subtraction rule. Proceeding, we have that y is equal to 4x squared multiplied by, this is going to give me x to the power of negative 1 over 2. 1 over the square root of x is x negative 1 over 2. I have plus 3x multiplied by, what's 1 over the square, what's 1 over root x is the same thing as saying, that's the same thing as saying that we have 1 over root x is the same thing as saying x negative 1 over 2 minus 2 multiplied by x negative 1 over 2. And proceeding, I can move forward by saying that y is equal to 4 multiplied by x 2 multiplied by x negative 1 over 2 plus 3 multiplied by x negative 1 over 2 minus 2x negative 1 over 2. A lot of indices, I also know that if I have a to the power of m multiplied by a to the power of n is the same thing as saying a to the power of m plus n. So this is why I can basically transform this to be x to the power of 2 plus negative 1 over 2 plus 3. This is going to be plus 3x 1 plus negative 1 over 2 minus 2x negative 1 over 2. I believe you understood what I just did there. So this is also going to say 4x 2 plus into minus 1 over 2, and that's we are going to have x 2 minus 1 over 2, because plus times minus is minus. So we have 2 minus 1 over 2, and 2 minus 1 over 2 is the same thing as saying 3 over 2. So I'm going to rewrite this as 3 over 2 plus, this is going to be 3, and then x to the power of 1 positive multiplied by this negative is going to give me negative. So I have x to the power of 1 minus 1 over 2, and that's going to give me 1 over 2. So what I have here will be x to the power of 1 over 2 minus 2x minus 1 over 2. Finally, what we have here is going to be 4x 3 over 2 plus 3x 1 over 2 minus 2x 1 over 2. Moving forward, we have that I can now differentiate the y over the x. It's going to be 4. I differentiate this, and then I'm going to differentiate this. If I differentiate x to the power of 3 over 2, what I have is going to be 3 over 2. If I differentiate x to the power of 3 over 2, that will be 3 over 2 x to the power of 3 over 2 minus 1. and differentiating that. So I'm going to have multiply by 3 over 2 x to the power of 1 over 2. 3 over 2 minus 1, I'm going to have 1 over 2 plus, this is going to give me 3. And if I differentiate x to the power of 1 over 2, I'm going to have x. I'm going to have 3 into 1 over 2. Differentiate x to the power of 1 over 2, I will have 1 over 2 x to the power of negative 1 over 2. And then finally differentiating x to the power of 1 over 2. Sorry, this is negative. This is negative. Negative sign here. So I'll have negative 1 over 2 x to the power of negative 3 over 2. My dy over the x. 2 can go into that, so I have 2 left. 2 times 3, that is 6x 1 over 2 plus 3 over 2 x minus 1 over 2. Negative here is multiplying negative here, that's positive, and I have 2 can go cancel out 2, so that's 1. So I have just x into negative 3 over 2. The next step is the y over the x is equal to 6 root x, because that's what x 1 over 2 means. So x to the power of 1 over 2 multiplied by 6 can be written as 6 root x plus, this is going to be 3 over 2 1 over root x. And this is just going to be 1 over the square root of, that's going to be 1 over the cube root of x. Which I can finally rewrite this as 6 root x plus 3 over 2 root x plus 1 over the cube root of x. So that becomes our differential equation for differentiate y is equal to 4x squared plus 3x minus 2. So did you get this? Was this what you got as your answer? You can pause the video now and compare your answers if this is what you got. If you didn't get this as your answer, or anything that is still the same as this, but maybe you rearranged, it was rearranged, but still correct, still this, then you can go through the solution again and find out where you made a mistake and learn from it. If you have a question, you can just feel free to ask me, send me a mail, send me a message, and I'm going to respond to you immediately.